log of 5 base A. Let's say I'm just telling you that it's 0.4136, and I'm also... You're doing a good job keeping me on my toes, birthday girl.
Thank you.
Do you have your first cup of coffee yet?
No.
You're saving it for...
I don't have time to go upstairs.
You've been too engaged in your Algebra 2.
I guess.
Alright, so if we know, like these are given to us, that's not the problem, those are given. And we want to figure out what the log of 20 base A is. Okay, so we're going to have to change log of 20 using these two. So we know the log of 5 and log of 2, but we don't know the log of 20. So what we can do is expand that to be the log of 5 times 4, even better, 5 times 2 times 2 base A. So using the product property, we can expand. So I changed 20. I did a prime factorization of 20. Made it 5 times 2 times 2. So now I'm going to expand that and say, well, that's the log of 5 plus the log of 2 plus the log of 2 using our product property. Once you've changed log of 20 to be these three things, then you can go back and say, well, I know what the log of 2 is. So I can replace my log of 5 with 0.4136 and my log of 2 with 0.1781 and 0.1781. Then you literally just add up those three numbers and we get our answer. So whatever that is, 0.4136, and we get 0.7698. So that's our answer, what log of 20 base A is. So you have to write it in terms of what we know, and then once we've done that, replace each of those with what it actually is, and then you can answer the question. Alright, so why don't you try this one? Let's figure out, given this, see if you can figure out what the log of 125 base A is. See if you can get 125 base A. Okay, so 125, we have these as our clues. We've got a 5 and we have a 2. We're going to do a prime factorization of 125, which is 5 times 5 times 5. So that's the same as 5 times 5 times 5. So we could use the product rule by saying now that it's the log of 5 plus the log of 5 plus the log of 5. And we know that the log of 5 base A is 0.4136, so we just do that 3 times. And whatever that is. 0.4136 times 3 gives you 1.2408. So that'd be our answer. Another way we could have done it is we could have recognized that 5 times 5 times 5, well, that's the same as the log of 5 cubed, and used our power property by taking that 3 and moving it out front. So it's 3 logs of 5 base A. And we know now that still the log of 5 base A is 0.4316, and we get the same answer. So 2 ways of doing the same problem. Questions on that? I'm going to give you one more. Alright, last problem. See if you can do the log of 2/5 base A. Try that one. I'm going to have to expand it all out here. I don't think the neck on my document cam is good enough. So number 3, the log of 2/5 base A. Alright, so if you're following along and understanding, you probably saw that we need the quotient rule where you divide them, and then you can rewrite them by subtracting. So it would be the log of 2 minus the log of 5. And then these are given to us. So 0.1781 minus 0.4136, because that's what the log of 5 base A is. And then we get our answer, 0.1781 minus 0.4136. Alright, so hopefully that helps you. We used all of the properties except for the change of base within these problems, so I'm not going to give you separate problems to try right now by expanding or condensing. Questions on any of this stuff? Raise your hand if you got negative 0.2355 for that one. All right. So hopefully, having seen that, you understand. Now, I'll take a picture of this, put this in the classroom. I'll just leave us in out of Teams here for the last few minutes. Let me know if you have any questions. Go ahead and keep working on your assignments. This is the last semester, year, course, or whatever, is going to be on 6.3 and 6.5. And this is 6.5 material, the log property. So this is the end of the new material that'll be on your last quiz. We're going to do some 6.6 stuff and do like a formative assessment, but as far as your last summative assessment, this is the last information that you'll need.